Hello and welcome to the next video for parametric equations. This video is going to focus on drawing parametric equations by hand. On the whole, this is actually relatively straightforward to do, and it harks back to a way that you used to plot graphs at GCSE. So let's have a look at an example and just get right into it. So we've got this example here. We're going to draw the graph given by the parametric equations x equals 3 sine t plus 2 and y equals 3 cos t minus 1. And we're going to choose the values of t between 0 and 2 pi. So what we're going to do is we're going to make up a table involving a bunch of t values. Now this table may well be given to you. If it's not, choose sensible breaks. In this case I've chosen pi over 4. And all we're going to do is we're going to work out the values of these two equations when t is this. Now obviously we've got 9 different values of t, so we don't want to have to put one in individually, so we can actually use our calculators to help us do this nice and easily. Because often for this question, unless it says find the exact values, leaving them as decimals is okay. So let's have a look at that. So we go to menu and scroll down to table. Press equals to select it. You'll see now we have f of x equals. So we're going to have to play around with the notation here, but it's okay. So we're going to type in 3 sine x plus 2. I know this is x and this is t, but that's the way the calculator does it. And we're going to press equals. Now see, we have now an option for a second function, so we're going to type in this one. 3 cos, again we're going to use x instead of t. And now we have an option for table range. So our start value is our first t value. Our end is the last one, so we can type in 2 pi. And our step is how we're getting from one to the next. So in this case, pi over 4. Once you've typed that all in, you press equals, and our calculator gives us all our values. So we don't have to actually physically work each one out. So this f of x column is what I'm going to put in my x row, and this g of x column is what I'm going to put in my y row. So you can see I've written in all of the values there and drawn some axes. Again, depending on how kind the exam is, they may give you the axes already. So I've looked and gone, well, my x goes from -1 to 5, so I've just gone a little bit further, and y goes from -4 to 2, so I've gone a little bit further. Now we've worked out all the x and y coordinates, we no longer need to worry about the t values. And this is something that confuses some students when plotting the graph. We're going to plot, these are the coordinates. So we've got coordinates 2, 2, 4.12 and 1.12, and so on. So what we're going to do is, much like at GCSE, we're going to plot those coordinates and then join them all up. Now what we're going to do is we're going to add a part B to this question, which is finding the Cartesian equation and its domain and the domain and range of the equation. So we've got, as a reminder, x equals 3 sine t plus 2 and y equals 3 cos t minus 1. Now handily, we already know that this is going to be a circle, so we know the equation is going to look something like this. But if we didn't know that, you need to know what to do with these trig questions. Hopefully, if you watched the previous video and had a go at exercise 8b from the Pearson textbook, you should have some understanding. But let's just go through this one here. The key thing is recognizing a trig identity that links the trigonometric functions in both equations. In this case, we've got sine t and cos t. Now, I know we've got a bunch of other stuff, but I'm not actually too concerned about that. So we know that there's only one trig identity that links sine and cos together with nothing else, and that's this sine squared t plus cos squared t is 1. So let's use that. So we know that x is 3 sine t plus 2, so that tells us that 3 sine t is going to be x minus 2. So sine t is x minus 2 over 3. Likewise, 3 cos t is going to be y plus 1. So cos t is y plus 1 over 3. And now we can use our trig identity. So x minus 2 over 3 squared plus y plus 1 over 3 squared equals 1. Now, to make this look more like a circle equation that we're familiar with, let's multiply through by 3 squared. And that's our equation. To find the domain and range, we do as we did in the previous video, but again, because we've already drawn the graph, it's actually very easy. We've already worked out all of the values for x and y, or not all of them, but a lot of them, between 0 and 2 pi, and we can already see our range and domain here. Remember, the domain is the limits of x, the range is the limits of y. So we don't actually need to do any further calculation because we've done it all already. So the domain, the x values go from -1 to 5, and the range goes from -4 to 2. And we're done. So I've got a second example here. What I'd like you to do is pause the video, have a go at it, and then I'm going to put up my answer so you can check yours. So you can see my answer here. Another reason why you draw your graphs in pencil. But it doesn't show up particularly on the video, which is my excuse. Not much of an excuse, but it's there. So we can see the graph. When we type in our values, we get these. Plotting our graph, we get, as hopefully you expected, this cubic shape. Obviously with this example, the scale's quite difficult, so chances are with this type of thing, they would give you the graph paper in the exam. Working out the Cartesian equation as well, a little simpler than the previous example. We're just rearranging to find x, so we get x cubed over 64. If you left it as this, you'd probably get away with it. It would depend on how many marks the question was worth. Then the domain and range, again, very straightforward. Because we've already worked out the values, we don't have to worry about anything wibbling about up here or down here. And that's everything with drawing parametric curves. You can now go away and find the chapter in your textbooks which practice that.